Okay, so I'd like to talk about these problems that involve limits because it seems there's some misunderstanding. All right, so what does this problem say? Let's see, it says fill in the blanks and give the example asked for. The definition of f of x goes to L as x goes to infinity is this. For any epsilon, there is an x, big X, such that blank less than epsilon if blank is bigger than x. So we've got two blanks to fill in. So what does it mean that the function f goes to L as x goes to infinity? Well, let's draw our axes, and then let's draw our function. Well, we can also draw L. L is going to be, we can think of L as a horizontal line, and the value of f is going to approach L. So if I get some function, so the function may be quite irregular, but what it's saying is that as you go out here, the function wiggles, but it's getting closer and closer to L. So this is my x-axis, this is f of x, and that's the value of L. Right, so what's happening here? As you go out this way, the function value gets closer to L. So as x increases, f of x gets closer and closer to L. So what does this mean? If fx gets closer and closer to L, that means that the distance here gets smaller and smaller. The distance between f of x and this horizontal line gets smaller and smaller. It means f of x minus L. Now, it could be positive difference, it could be a negative difference, but it's still going to be small. So it gets small. Okay. That's what it means that f of x goes to L. It means f of x minus L gets small. Okay, so look at one thing. You've got two things going on. You've got x increasing. You got x getting bigger. Okay. So that's this part. X is getting bigger. X is increasing. And this is getting smaller. All right. So you've got these two things going on. One thing gets big and one thing gets small. Now compare that up here. Up here it's saying that this thing here gets small when this thing here gets big. So what's getting small? What's getting small is the difference between f of x and L. So in fact, that's what the answer is in this box here. What goes in this box is in fact f of x minus L, absolute value. And what's getting big? What's getting big is little x. Right? There's a difference between little x and big X. He's taking that, this big X is something out here. If this big X is large enough, then this distance is going to be small. That's the idea. The larger that X gets, the larger that this big X gets, the smaller the distance I can expect between these two. The way you do this is you set a distance, you set a vertical distance, epsilon, and you say, well, there is some value of x far out, I don't know how far out, but far out, there's some value of x that makes it so that f of x is always within epsilon of L. Okay. All right, so that's number 3. If I look at number 4, what I was hoping people would see the close relationship between number 3 and number 4. Let's see here. Okay. All right, so let's do this. Because number 4 really is very, very close to number 3. So let's insert that and we'll see what to do with that. Oops, wrong place. Let's put it here. I'm going to do both of them. I'll copy both of them because I'm going to use 3 to do 4. So what I want to do is number 4. So this is what I want to do. All right, give a correct definition of f of x goes to 0 as x goes to minus infinity. Now notice the difference between problem 3 and problem 4. It's not big. Here, instead of L, I have 0. And instead of x infinity, I have x is minus infinity. Right? So really what I need to do is modify my answer to number 3 to get an answer to number 4. Because it's the same structure. So what's the picture here? I'm not going to use all the fancy colors this time. All right, so I got my function, but now I'm looking when x gets small. So what it's saying is that the function value is getting closer and closer to 0. All right, so in fact, the definition is going to be exactly the same as this definition, only replace the right values. So I can just say the definition of f of x goes to 0 as x goes to minus infinity is for any epsilon and we should probably put epsilon greater than 0, but he just said for any epsilon. Okay, there is an x such that now before we had L, now we have 0. So here we're just going to have f of x minus, instead of f of x minus L, it's going to be f of x minus 0. Is less than epsilon. Now here, what are we looking at? We're looking at at x goes to minus infinity. So it's not that it's not that little x has to be bigger than big X. It has to be little x is less than little x. Little x is less than big X. So there's some big X here that if little x is smaller than big X, then the value of f is very, very close to 0. So problem 4 was just modify problem 3. Slight modification. In this case, the limit L is 0. And instead of x getting big, x gets big, well, it gets big negative, which is the same thing as saying it gets small. Right? So hopefully that helps.